We're moving into ADHD now. I'm really kind of talking about the different types of ADHD, that sort of thing. The DSM-5 isn't changing the category of ADHD very much, but how common is it? Well, most research indicates that ADHD is one of the most common disorders of childhood. Prevalence is estimated 3 to 7% of the elementary school population, and the disorder occurs more often in males than females. It's been recognized for many years. Back in the 40s it was called minimal brain dysfunction. It changed to the 60s to hyperkinetic reaction of childhood. 80s to ADHD, and the 90s ADHD. The 80s was ADD. So let me go into just a brief history because, you know, it's fun. 1902, Still, who wrote the lectures for the Royal College of Physicians, published a series of lectures on children that were in his practice. Specifically 43 children he had identified as having aggressive, defiant, and resilient to discipline problems. They were excessively emotional, had little inhibitory volition, and needed immediate gratification. And he saw that most of them were under the age of 8 when their symptoms started occurring, and they were a ratio of 3 to 1 male to female. So this is one of the earliest known writings about ADHD, or the symptoms of ADHD that we see now. The encephalitis outbreak of 1917 turned people's attention to the fact that ADHD might actually be an organic thing, because children with the children who survived the encephalitis outbreak showed behavioral characteristics of impulsivity, hyperactivity, social disruption, and significant attention deficit. They also had memory impairment. Another term to the fact that this is an organic problem, instead of just behavioral, was in 1950 when they had the frontal lobe ablation studies of primates. They took monkeys and they ablated their frontal lobes to see what happened, and they found that these monkeys now had problems with staying on task, with paying attention. They were excessively restless, always on the go. They didn't have interest in things like they used to, and they were behaviorally disorganized. And then in the beginnings of child psychopharmacology, amphetamines were being given out as treatment between 1930 and 1940 is when that started. And this corresponded to Strauss's work and the coining of the phrase minimal brain dysfunction, when Strauss and his colleagues attempted to isolate the characteristics of this disorder. And what they were finding is that children with this disorder had all of the diagnostic criteria that we've been talking about, but Strauss's work was really focused on treatment. And one of the best things that came out of his work was the small classroom sizes and how to help children really pay attention. He had the teachers come in wearing very simple clothes, no jewelry, no makeup. There was nothing on the walls, and they had the very small class sizes, and they were found that children without the external stimuli could actually pay attention and focus and learn. And so that was one of the best things that came out of his work. In the 1960s, hyperkinetic disorder was coined by Stella Chess, who was also working with children with attention deficit disorder. And she wanted to indicate that ADHD, of what we know now, specifically the hyperkinetic disorder of her age, was not due to a badness, of the child, but more due to the brain function. Presumably those who were brain damaged in some way. And she was instrumental in helping the DSM-2 get it placed in as hyperkinetic reaction. 1980s focused on more sophisticated medical approaches to understanding this syndrome. The role of brain function was one of the biggest things that was included, including cerebral blood flow and neurotransmitter deficiencies, whatnot. Newer imaging techniques were also really highlighted in the 80s and 90s, and the new body of literature started talking about abnormalities in the brain. These included PET scans, MRIs, fMRIs, if you're interested in looking up more information about that, and evidence-based practices to really help people with ADHD. Catecholamine Hypothesis took sway in the 1980s. And everyone, because of the neuroimaging, specifically dopamine, started saying, oh hey, it's because of dopamine and norepinephrine, and there's a disconnect there, there's a problem with the pathways in the brain, and that's what causes ADHD. However, in 1990s and through now, Corbetta and, coming back to Genzenegger's research is really showing a lot more. Corbetta studied brains that had microlesions on them. Specifically, he found that these brains had microlesions that occurred in the 3rd trimester of pregnancy. It was a fetus caught the pathogen and actively but indiscriminately caused scars to their brain. Genzenegger replicated this with rats because we know Genzenegger and his rats. He produced the same pattern of development in the brain by causing microscars in the 3rd trimester and then watching how the brain developed. And what he found is that our brains all develop in the same way. And it didn't matter where he put the scar on the brain, that it was ended up in the thalamus, prefrontal cortexes of the frontal lobes. So, Kelly Schaefer found the same sort of things when she was looking at humans. She in fact found that 70% of the people in her study with learning disabilities had these microscarrings in their thalamus. So the theory, the newest theories that are coming to light with regard to ADHD is that our brain, as I told you in the beginning, develops in the same predictable pattern. But the brain will cannibalize from secondary systems that are not necessarily developed yet in order to meet the developmental milestones in the predictable pattern that normally happens. So for instance, that's why we always ask about milestones. Everyone learns to walk and talk before they learn to read and write, before they learn higher level math. You know, that's the predictable fashion. And if those secondary networks are borrowed from, cannibalized from, if you will, and the cells from, say, the frontal lobe are taken back into the other areas of the brain so the person can read, write, walk, and talk, they will then have deficiencies in their frontal lobes, meaning they'll have harder time paying attention in class, being overstimulated by external stimuli. They'll be having a lot of trouble with attention and a hard time staying on task and focused. Why? Because their secondary network that's not completely developed yet has already been cannibalized so that they can meet their milestones like other children. So that's one of the newest theories that's out of these guys' research. And if you're interested, look up Corbetta and Genzenegger so you can learn more about their research in these areas. The reticular activating system, coming back to this, how does this control loop play a part in that? Well, if the RAS is the center for consciousness and coordinates learning and memory, which then supplies appropriate neural connections necessary for smooth information processing, clear, non-stressful attention, etc., and the cells here have been borrowed so that people's brains, which are developing in a predictable fashion, are not there. The cells are not there, so this system is working, in essence, with faulty hardware. There's limited production, and the neural networks are not connecting correctly. So that's why we have problems with people who have attention deficit disorder. That's why they have problems with learning, memory, attention, and executive functioning. And the biggest thing for diagnosing ADHD now is looking at executive function. A 2010 study by Brotman using fMRI to distinguish ADHD from severe mood dysregulation and bipolar in youth used fMRIs in a comparative study, and they were looking at what they found was that the amygdala highlighted in different ways. For instance, subjects were shown a random selection of 32 adult faces and different races, different facial features, and different genders. And they were making happy, angry, fearful, and neutral faces. Study participants were asked to rate these faces in terms of perceived threat, subjective fear, and nose width. And the study found that compared to healthy subjects, those with ADHD manifested hyperactivation in their amygdalas when they saw scared and neutral, when they were rating scared faces and neutral faces. In contrast with other kids with like severe mental dysregulation, who were able to activate regardless. So what this really came down to is that we need both intense emotional information to correctly identify emotions for kids with ADHD. They have harder time correctly identifying emotions.